In this module, we are going to try to get an understanding of what is psychrometry. And we will look at some of the underlying constants and also some of the theory. Now, what is psychrometry? Well, if we look into the Webster Dictionary, it defines psychrometry as a science that deals with the physical laws that govern the mixture of air and water vapor. So essentially, we are going to be looking at a mixture of air and water vapor. Now, some of you may know about an organization called the American Society of Heating, Refrigeration, and Air Conditioning Engineers. The acronym is ASHRAE. Now, ASHRAE defines psychrometry as a branch of physics that is concerned with the measurement or determination of atmospheric conditions, particularly the moisture in the air. Now, this area is important to those who handle food, since food is exposed to air during handling and storage. And moisture transfer between the food and air can dramatically impact the food quality. You know that if you leave something in a moist environment, any dry food, it will pick up moisture and it will get soggy. Also, in certain processing operations, such as drying, we will be setting up a gradient of moisture between the air and the food so that we can extract that moisture out of the food in order to reduce its moisture content and thus perhaps extend the shelf life of that food. So understanding the properties of moisture and air is really important in a variety of food processing operations. When we refer to air, we imply usually a mixture of dry air and water vapors, vapors that are in gas state. Now, you know from your chemistry that air contains a number of gases. For example, we see in this table that largely air has nitrogen and oxygen, and smaller quantities of gases such as argon, carbon dioxide, helium, hydrogen, methane, etc. Let's consider a certain space. Now, this space, let's say, is filled with dry air and water vapors. Thus, we have a mixture of two components, dry air and water vapors. Note that water vapors are always in gaseous state. Very rarely do we encounter water vapor in liquid state. That is when we have fog. Now, if you live in a place where I do, here in Northern California, in winter, we get a lot of fog. That is where you encounter condensed vapor in liquid state. Both dry air and water vapor are considered to be nearly ideal gases. Therefore, they will follow certain laws. Again, you will recall from the course in chemistry that you took that PV equals nRU times T, where P is pressure, V is specific volume, N is the number of moles, Ru is the universal gas constant, and T is absolute temperature. So the units, T is in absolute temperature, K, Kelvin. For pressure, we have kilopascals. For specific volume, we have cubic meter per kilogram. And for the gas constant, we will look at in the next module.